Welcome to this explainer. Whenever we think of robotics, our minds usually jump straight to futuristic laboratories or cutting-edge tech companies in the 21st century, right? But what if I told you the true foundations of modern robotics and automation were actually laid down over 800 years ago? Let's take a journey back in time to uncover a hidden history that is absolutely going to change the way you look at the machines all around us.
So let's get right into it. Who do you think invented the first programmable robot? If you're guessing some brilliant engineer from the 1950s or maybe even Leonardo da Vinci during the Renaissance, you're actually off by a few centuries. To find the real answer, we have to travel straight to the heart of the Islamic Golden Age.
Section 1. The Father of Robotics. Meet Badi al-Zaman Abu el-Iz Ismail ibn al-Razaz al-Jazari, or to keep it simple, al-Jazari. He was born around 1136 CE in Upper Mesopotamia. This was right during the Islamic Golden Age, which was this incredibly vibrant cosmopolitan era of intense scientific inquiry. For over 25 years, al-Jazari served as the chief engineer at the Artukid court in what is now modern-day Turkey. And in 1206, he completed his life's work, a manuscript that would quietly but completely shape the future of engineering.
Now, what's really fascinating about his work isn't just that it was a list of neat ideas. His 1206 masterpiece, the Book of Knowledge of Ingenious Mechanical Devices, was literally an instruction manual. Unlike a lot of other inventors of his time who fiercely guarded their trade secrets, al-Jazari provided step-by-step construction blueprints, exact measurements, and material specs. He wanted his knowledge to be reproducible, making him a true visionary precursor to the modern engineering community.
Section 2. Clocks, Computers, and Cams.
Okay, to really grasp his genius, we need to ground ourselves with a core definition here: automata. Basically, these are mechanical devices capable of performing complex tasks autonomously, and they often imitate human or animal actions. Al-Jazari was developing these automated, lifelike machines a full 2.5 centuries before Leonardo da Vinci ever sketched his own mechanical knight.
Let's see how this actually played out in reality. Take a look at the magnificent elephant clock. Inside this elephant is a concealed water bolt that slowly sinks over a 30-minute cycle. Once it sinks, a float sensor triggers the release of a metal ball, which then falls right into the mouth of a mechanical dragon. The dragon pivots, strikes a cymbal, and the entire system resets itself. It's a perfect 13th century physical manifestation of the modern robotics loop: sense, compute, actuate.
And this illustrates an even more massive leap forward. Notice the comparison we're making here. Al-Jazari's castle water clock, which was this towering structure over 3 meters tall, paired right next to a modern analog computer. Why make that comparison? Well, because the castle clock is widely considered the very first programmable analog computer in history.
You see, this thing didn't just tell the hour, it tracked the sun, the moon, and the zodiac, using a highly advanced feedback-regulated float valve to maintain a steady flow of water pressure. But the real genius? Users could physically reprogram the machine. By moving pegs and counterweights on its surface, they could adjust for the changing lengths of days throughout the year. That is an absolutely incredible feat of adjustable functionality for the 1200s.
Section 3. Automata and Ancient Cybernetics.
So, take a look at this definition of cybernetics: the science of communications and automatic control systems. Now, the mathematician Norbert Wiener officially coined this term in 1948, but if we look at the historical record, al-Jazari was already mastering hydromechanical feedback and balance control systems 8 whole centuries earlier.
Let me show you exactly what I mean here. On the left is al-Jazari's musical boat, which was designed to entertain guests with a literal mechanical robotic band. The secret to the music was a rotating drum covered in pegs. By moving those pegs into different holes on the drum, the operator could actually change the rhythm the mechanical musicians played. It is the exact same physical logic used on the right in early modern drum machines or player pianos. He essentially created an early form of a stored, reprogrammable system. But he didn't just build these machines for entertainment at parties. Al-Jazari designed an automated basin for ritual washing, or wudu. This was a humanoid robotic servant that stood by a basin. When a user interacted with it, siphon-based mechanisms and precision float valves would trigger timed release sequences. It dispensed the exact amount of water needed for each phase of washing. That's an extraordinarily early form of user-centered, automated, assistive technology meant to help people with their daily hygiene.
Section 4. The Revolutionary Crankshaft.
Now, the crucial point lies right here. This is Jazari's twin-cylinder suction pump. What you are seeing fundamentally changed the course of mechanical engineering. Why? Because it solved a massive problem. How do we efficiently manipulate continuous power and motion to do heavy work, like lifting water for agriculture?
The answer is right here in this direct comparison. On the left, Jazari's pump uses an early crankshaft and connecting rods to convert the continuous rotary motion of a water wheel into the back and forth reciprocating linear motion of pistons. Does that sound familiar? It really should, because looking at the right, that exact mechanical conversion, rotary to linear motion via a crankshaft, is the fundamental driving principle inside the internal combustion engines that power our modern automobiles and trains today.
Let's walk through exactly how this elegant setup worked. Step 1. The river turns the water wheel, giving you a continuous rotary input. Step 2. That spinning axle turns the crankshaft, which pulls one piston while simultaneously pushing the opposing piston. They operate entirely out of phase. And finally, Step 3. Flap valves, which are basically early one-way valves, ensure the water only ever flows in one direction. By opposing those pistons, Jazari minimized intermittent flow, meaning the pump delivered a perfectly smooth, continuous stream of water. It was an absolute masterpiece of efficiency.
Section 5. Legacy and Modern Technology.
I absolutely love this quote because it captures his mindset perfectly. Jazari wrote that techniques that cannot be translated into practice are essentially worthless. He was a deeply, deeply practical engineer. He wasn't just building clever toys for the wealthy court. He was explicitly designing systems to solve real societal problems, like municipal water distribution, crop irrigation, and accurate timekeeping.
And think about how perfectly his work aligns with our modern educational frameworks. We talk so much today about STEAM, science, technology, engineering, arts, and mathematics. Well, Jazari was literally doing it 800 years ago. He mastered fluid dynamics for his science. He pioneered programmability for technology. He invented the crankshaft for engineering. His precise astronomical clocks relied on heavy mathematics. And the arts? His machines were beautifully decorated with Indian elephants, Chinese dragons, and Persian carpets. He fused beautiful, multicultural artistry right alongside hard mechanics.
Which brings us to his ultimate legacy, his meticulous documentation. Because he recorded every single gear, every valve, and every measurement, his knowledge didn't die with him. In an era where artisans fiercely guarded their trade secrets, Jazari's open, pedagogical approach makes him kind of a spiritual ancestor to today's open-source engineering community. He wanted you to build his machines. He wanted to teach the next generation.
So, here is a question to leave you with. How many devices in your home right now rely on 800-year-old Islamic engineering? The next time you start your car and the crankshaft turns, or you set a timer on your programmable coffee maker, or you see a robotic arm moving on an assembly line, I hope you remember the chief engineer of the Arctic court. Jazari's brilliant mind is proof that human ingenuity spans across centuries and cultures, and the roots of our automated future are buried deep, deep in our ancient past. Thanks for joining me on this explainer, and keep questioning how the world around you actually works.